Good morning, everybody. Okay, today's the last day we're meeting in person. Starting next week, for the next 4 weeks, we'll be online. So you can either sleep in or attend online, in person online, synchronously. All right, now we're going away from the real number system. Remember, the real numbers are, we had the counting numbers or the natural numbers. What were those? What are counting numbers? Don't you see? Do you see it's up there? In all my classes, I forget that. So what are counting numbers?
Numbers on the number line from negative infinity to positive infinity.
That's the most common mistake people make. That is a number system, but not the counting number. If I asked you to count, I said count to 10, where are you going to start from?
1 or 0, maybe.
Nope. Yeah, nobody ever starts at 0, 1. So if you're playing hide and seek, say, okay, 1, 2, 3, all the way to infinity. Those are the counting numbers. But you're right. Some people, the geeky nerds, will start from 0. We call whole numbers, because it begins with a whole, the 0, 1, 2, 3, all the way to infinity. Then we have the other side of the folded page. We have the integers. The integers start from negative infinity, go down to 0, and then start up again on the positive side. So the integers go from negative infinity to positive infinity. But they're numbers, they're not anything else. Now, for the numbers between 0 and 1, 0 and 2, we call those quotient numbers. Oops. Or rationals. And those are in the form A over B, where A is bigger than B and B never equals 0. No. A is less than B, I'm sorry. Because these take the place of every number between 0 and 1. And between there are infinitely many of them are between those. So we can go infinitely small, infinitely larger. So there's an infinite number of numbers in there. So we have quotient numbers, which are the rationals, the fractions. Those are what we call real numbers. But now we have a new set of numbers called the complex numbers. Complex numbers were invented to help scientists answer questions. For example, this is where it all came about. We know what square root of 9 is. I hope. What's square root of 9? Because 9 is made up of 3 times 3. Remember, there's an invisible number there. What number is supposed to be there? 2. Which means I need 2 of a kind to take it out of that radical. So that's how come it's 3. The square root of 18. What's 18 made up of? 2 times 2 times 9. Yeah, you were right. And then 9 breaks down to 3 times 3. So according to the rule of square roots, if I have 2 of a kind, that goes out in front. And whatever's left stays inside there. All right, so that's everything's great when it comes to that. I mean, even square root of 5. We can't simplify that any further, so it's just square root of 5. But what's the square root of -4? -2 times -2 is +4. So we can't have -2, -2. We can't have +2, +2. So we have a problem there. But it's going to happen. It's going to come to us eventually when we get a problem where we have a negative inside the square root. Up until now, we will say that there's no real solution until now. What we have to look at here are called complex numbers or imaginary numbers first. Imaginary numbers are numbers that have the letter I next to it. What the I represents the square root of -1. So anywhere you see a square root of -1, that's the same thing. You put an I in its place. Or conversely, if you have an I, you know that it's supposed to be replaced with square root of -1. Now, how does that fit here? -4 is made up of -1 times 4. We can now split these two. We have square root of -1 times square root of 4. What's the square root of -1? I. Square root of 4? So the answer is 2i. So this is called an imaginary number. Why is it called an imaginary number? Because you can't graph it. If you had a piece of paper and you try to graph that, it would be somewhere above the piece of paper somewhere. Let's look at the rules of square root or radicals. If I have 2 numbers inside there, or a number and a letter, I can split those up. And do both of them separately. If I have a rational radical number, rational means fraction, radical means square root, I can split those up as well. example of this one. Remember, what this means is if I give you this, you can put it to this if it makes it easier. For example, if I gave you square root of 15 over square root of 3, what would that equal? How would you simplify that? Yeah, since we can't do anything with this, because 15 is made up of 3 times 5 over square root of 3. I can split those up. And the square root of 3's cancel. And so my answer is square root of 5. Yes, I could do it that way. Or since I can't do anything individually, I could put them together. And we know that 15 divided by 3 is 5. So it's square root of 5. So there is no wrong way. As long as you follow the rules, there is no wrong way of doing the answers. So I equals what? Square root of -1 or -1. So if I have I squared, what is that going to make it? Very good. That's exactly right. Because if I have square root and I square it, it means these cancel. So I just have -1. So anytime you see an I squared, that equals -1. In other words, if I had a number like that. In other words, what the rule here is you never want to have an exponent on an imaginary number, on the imaginary part. If it's squared, what does it become? What is I squared?
-1.
-1. So we replace I squared with -1, which makes it -5 now.
Wait, I have a question. If
Yes.
I is -1 and you're
Yes.
squaring that, why doesn't it become +1?
Because I'm not squaring -1. I'm squaring I is square root of -1.
Oh, okay. Makes more
When I
sense. Thank
square it.
you.
Yeah. Yes, yes, yes. So I'm squaring the whole equation. So this is what you have to remember it is. Now, the reason being, because if I had square root of 2 times the square root of 10, can I do anything with those?
No.
Well, let's look at our properties that we have so far. We can go both ways. So if I have two of them that are multiplied separately, I can put them both together. So this one, I could put 2 times 10. Now, why is that going to make it better for me? Because what is 10 made up of? 2 times 5, right? Now, since I have two of a kind, it goes out in front. So there's my answer. Simplified. And it doesn't matter what we have. We have square root of 2 times square root of 3 times square root of 5 over square root of 20. What would be the most logical way of doing that?
Combining the top terms to square root of 2 times 3 times 5.
Okay, that is one way. Let's see what happens here. So if we combine them, what do we get? We get 2 times 3 times 5 over square root of 20. Remember, it's division, so we want to simplify it. So what are you going to do next? Remember, there is no wrong answer as long as you simplify it at the end.
So could we expand out the 20 there to square root of 2 times 2? Well, no,
Yeah,
times
because that's
5,
4
yeah.
times 5. 4 times
Okay.
5 is 20. Yeah.
And then would the 2 on top? No, because they don't cancel out between the top and the bottom, right?
But because they're both rationals, I can make it one big one. So now the 2's cancel, the 5's cancel. 3 over 2, which is square root of 3 over square root of 2. Okay, that's one way you could have done it. We could have done this earlier. We could have done it this way. We have square root of 2, square root of 3, square root of 5. 20 breaks down to 2 times 2 times 5. Leave the top alone. So now I can separate each one of those. And then cancel, since they're all multiplied, I can cancel what's in common. We get the same answer. That's what I'm saying is there is no wrong way. As long as you follow the rules and apply the rules correctly, you'll get the same answer. And there's a special rule about this type of question in a minute we'll get to shortly. Solve for x. If I gave you this equation, it's an equation because there's an equal sign. All I have to do is say solve. What do you do first?
Add 1 to both sides.
Right. We have to keep all the x's on one side and move everything else to the other side. So we add 1 to both sides. We have x squared equals 1. Now what? Remember, you're not done until your variable equals something. That's what equal sign tells us to do. Or are we done? No, because it's got a square. How do we get rid of the square? What's the opposite of square? Square root. Okay, here's a rule. This is what A is a number. Any number. If you square root anything that has an even exponent, then you have to put a plus and a minus in front of the other side. Because the square root and the square will cancel. The answer is going to be plus minus whatever is on that other side. Why? Why is that a rule? And only for even exponents. For example, if x squared equals 4, normally you would just take the square root of x squared and the square root of 4. Those cancel, so you have x. What's the square root of 4? 2. Is that a right answer? Can you test it? Yeah, if I put 2 inside there, 2 squared is 4. Is that the only one? No, because I can also put -2 inside there. -2 times -2 is +4. So that's how come we make it a positive and a negative. Only for even exponents, because they come in pairs. If the exponent is odd, the answer is what it is. If the answer is positive, the answer is positive. If it's negative, it's negative. It's not both. In other words, cube root of -8 well, I'll show you in a second. In other words, what is 8 made up of?
2 times 2 times 2.
Right. And they're all negative, so they all have to be the same. There's 3 of them, and that's all I need is 3 of them. So the answer is -2. Because there's 3 -2 inside there. This is the root. So the purpose of the root tells us the number of times a value must be repeated to remove it. From inside of the radical. So since that's a cube root, I need 3 of a kind to take it out from the inside. If it's a square root, I only need 2 of a kind. So far, so good. Okay, so we figured out this one then. It's those cancel, so we have x is equal to the plus and minus of square root of 1. What's the square root of 1? One, yeah. What times what is 1? Times 1. So the answer is x equals plus or minus 1. Because if I square it, it becomes positive. 1 minus 1 is 0. As opposed to this one.
So would this be instead of x squared equals -1, would it be x squared equals I?
Nope. So you said, good try though. I see where you're getting at, but nope. So we have x squared equals -1. To get x by itself, what do? We square root both sides. So we have a plus or minus square root of -1. So x is equal to a plus or minus I. And since I doesn't have a sign, really, it's just I, it represents the square root of -1. That's why we write I squared is equal to -1. And therefore it becomes I. Now, with all these rules, square root of 4 times the square root of 3. Simplify that one. Okay, I should inside the square root of 4 like this. And then what do? You can. So that becomes what? Do we have 2 of a kind? Here's 2 of a kind. Where does it go? It goes in front. I threw this one in there for a specific reason. Yes, you got the right answer. You're bound to if you do all the rules correctly. But look at the equation. What's the square root of 4? That's like, the reason I put that one there is because we're looking for more complex things. Don't, I mean, if it's simple, trust yourself. It's going to be that. It's the same answer. It's just it took all the steps out of it. Okay, now let's look at this. Square root of 3 times square root of 5.
So we can't really do anything with those. So does it become square root of 3 times 5?
Yes, which makes it square root of 15. As far as we can take it. The reason I put these examples there, because that's using the property of, remember, the property. Oh, crikey. I gotta plug in my machine. How's this? Because now let's look at this example. What's that one going to be? Okay. Which would make it what? Like that? Well, no, 2 and 3 are prime numbers. They can't go any further. So if you could have done that, you would have done that here. And that's why simplify whenever you can. If you can't simplify, then you multiply them together and you're done. But no. You were just the only one brave enough to answer. Let's see what happens here. Let's look at both of these numbers separately. Square root of -2 is actually square root of -1 times 2, square root of -1 times 3. So I can split these up. I have square root of -1, square root of 2, square root of -1, so that one becomes those. This one becomes those. What's the square root of -1? Square root of 2. Square root of -1 is I. Square root of 3. So we have I times square root of 2, square root of 3. I times I becomes I squared. Square root of 2, square root of 3 becomes square root of 6. What is I squared? -1. So the answer is negative square root of 6. You did the most common mistake anybody does with these things. Most common is they just went ahead and multiplied by, that's what the rule says. I multiply what's inside there. But this one supersedes it. The order of operations says we have to do this first. We have a complex number. We split those up. And that makes it I radical 2, I radical 3. Because of the order of operations, we have to split them up. Example 1. Simplify that number. You should be done already. What is it? If there's a negative inside the square root, what do you get? You get an I. So that takes the square root out of there. Can square root of 7 go any further? No. So that's your answer. Square root of negative 16. What's that one going to become? I what? Square root, but I took care of the negative. That makes it I. So what's the square root of 16? Four times 4 is 16. So it's you're right, you're getting there. Yes. So the answer is 4I. Negative radical negative 13.
Negative I square root of 13.
Very good. Yeah, the negative stays where it is in front. The negative in the inside becomes an I, and all we have left is the square root of 13. Negative square root of negative 64. What's the square root of 64? If you don't know it automatically, then we could just do this tree. We know a 2 goes in there because the last number is an even. 2 goes into 6 3 times. 2 goes into 4 twice. 2 goes into 3 once with 1 left over. 2 goes into 12 6 times. 2 goes into 16 8 times. 2 goes into 8 4 times. So it's 2 times 2. So it's 1, 2, 3, 4, 5, 6. Two times two times two times two times two times two. We need two of a kind. There's one, there's two, there's three. So everything's out of the radical. 2 times 2 is 4, times 2 is 8. So the answer is negative 8i. All right, let's look at the last example here. E. Square root of negative 48. So what do we do with the negative inside there? It becomes an I. So 48 breaks down into 2. 2 times goes into 4 twice. 2 goes into 8 4 times. 2 goes into 2 once. 2 goes into 4 twice. 2 goes into 12 6 times. 2 goes into 6 3 times. So it's 2 times 2 times 2 times 3. So here's a pair and here's a pair. And the only thing left inside there is a 3. So the answer is 4i radical 3. Okay, so that's how we simplify the radicals. Why do we have to know that? Is because now we're going to define complex numbers. Complex numbers are made up of two distinct numbers. A real number, which is from between negative infinity to positive infinity, and an imaginary number in the form bi. Where b can be any number. Where b is any number between there and there. So complex numbers look like this. A plus bi. That's a complex number. Remember I said beginning of semester that every number is a fraction? Every number. So likewise this. Every number is a complex number. Is that complex? Yeah, it's got a real number plus a real number I behind it. Is that a complex number? Yeah, that's a real number. That's a real number. Is that a complex number? Yeah, because
No.
it has a real number here and a real number in front of the I. Is that a complex number? This is the same thing as 0 minus 4i. So it is a complex number. Is that a complex number? 2 plus 0i. So that's a complex number. Every number can be written as a complex number. It's just that A and B can be positive, it can be negative, they can be fractions, they can be 0. So that opens a whole can of worms for us. Now we're going to talk about the algebra of complex numbers. Since we have an equation, we can now have the algebra of complex numbers. Remember, whenever I say algebra of anything, what does it mean? It means I can do these operations on them. Add, subtract, multiply, divide. That's what algebra means. That's all we do in algebra course is add, subtract, multiply, divide in different formats. So addition. That's addition, subtraction. Three plus 2i plus 5 plus 7i. Order of operations. Can we do anything inside the parentheses? No. So we have to get rid of the parentheses. What do we do with the first parenthesis? There's nothing in front of it, so we just drop it. And the second parenthesis in front of there is a positive 1, so I distribute the positive 1 inside there. So I get a positive 5, positive 7i. Yeah, just drop the parentheses. Remember, whenever you remove parentheses, combine like terms. So we got rid of the parentheses. We combine like terms. The 3 plus the 5. The positive 2i, the positive 7i. So 3 plus 5 is 8. Positive, positive makes it a positive. 7 plus 2 is 9i. And there's your answer. Four plus 5i minus 6 minus 3i. Let's look at subtraction. Do we need the first parentheses? No, so I can just drop the first parentheses since there's nothing in front. How about the second parenthesis? No, I can't just drop it because I have a negative 1 in front of it. I got to change every sign inside there. So that positive 6 becomes a negative 6. This negative 3 becomes a positive 3i. So I have 4 minus 6. 6 is bigger, it's negative. 6 minus 4 is 2. The 3 and the 5 are both positive, so the answer is positive. 5 plus 3 is 8. And there's your answer. All right, let's switch it up a little bit. Simplify this one. I stopped because I ran out of room. All right, we can't do anything inside the parentheses, so we have to get rid of the parentheses. So negative times positive is negative. 2 times 3 is 6. Negative times positive is negative. 2 times 4 is 8i. Positive times positive is positive. 5 times 1 is 5. Positive times negative is negative. 5 times 2 is 10i. Negative times positive is negative. 3 times 2 is 6i plus 1. All right, so we have a negative 6 plus 5 is negative 1. Negative 1 plus 1, 0. So all of these numbers wash each other out. So now for the i's, they're all negative. So the answers are going to be negative. 10 plus 8 is 18. 18 plus 6 is 24. I. And there's your answer. So that's addition, subtraction of complex numbers. Difficulty level? Easy? Okay. Yeah, the hardest part is making sure the signs are going to stay right. Especially now that we're going to do multiplication. With multiplication, we've already done some of those. We had 2 times 3 minus 4i. So all we do here is distribute. 6 minus 8i. What if we had 2i times 3 minus 4i? Because the coefficient can be anything. It could be positive, it could be negative, it could be imaginary, it could be real number, it could be complex, it could be anything. So distribute. 2 times 3 is 6i. Positive times negative is negative. 2 times 4 is 8. I times I is I squared. Remember, you cannot have exponents on i's. So what does I squared equal? -1. So the only thing, if you have an I squared, because what it does, it becomes -1. So negative times negative makes it a positive 8. So your answer is 8 plus 6i.
Hey, I noticed when you're solving these that you always put the real number in front of the equation. Can we just do that? Is that what we should always do? And then have our
Yeah,
6i?
because
Okay.
that's the format of a complex number. A plus bi. Yes. Good observation. Yes, that's the reason I wanted to show that. Whenever you write these things, The real number goes first, imaginary always goes second, because that's the format of a complex number, a plus bi. Good catch. So now, basically, let me give you a clue here. Whenever you have an I squared, you do two things. One, drop the I squared, just get rid of it, and change the sign of its coefficient. So whenever you have an I squared, just drop the I squared and change the sign in front of the number. That's what we did. We have an I squared, we got rid of it. And all we did was change that sign. That's the final answer. We can skip this middle step. Or you can do it if you like it this way, you can do that. But that's all that really happens. Okay, now we have two complex numbers, binomials. Although I don't like using what's called the FOIL method because it makes you memorize one thing and one thing only. Because this FOIL method only works for this type of equation. Nothing bigger, nothing smaller. So that's just memorizing one thing for one thing only. It's really distributivity. I'll show you what I mean in a minute. But how many of y'all remember FOIL? Okay. So what that means is every term in this first parenthesis multiplies to every term in the second parenthesis. We have two terms here. We have two terms here. When we multiply them, we should end up with 4 terms. 2 times 2. So let's see what they are. So the first one, 2 times 5 is 10. Positive times negative is negative. 2 times 4 is 8. I. So that does it for the first one. It multiplied both of those. So now the second one. Positives. 3 times 5 is 15. I. Positive times negative is negative. 3 times 4 is 12. I times I is I squared. Those are our 4 terms. We got rid of parentheses, so we combine like terms, the middle terms. Negative 8, positive 15. 15 is bigger, so the answer is positive. 15 minus 8 is 7i minus 12i squared. So what do you do with I squared? Yeah, you can change it to -1. All that does is change the sign in front of the number. So from negative, it becomes a positive. Because I squared becomes -1. Combine like terms. 10 plus 12 is 22. And there's your answer. All right, let's look at example 3. A says -16 times -25. What's that one?
Square root of 4 times 5. So square root of 20.
That's the answer? Can you simplify any further? Let me stop you. It's wrong so far. Because remember, whenever we have radicals in complex numbers, here's a negative in 5 there. So it's an I square root of 16. There's a negative, so it's I square root of 25. What's the square root of 16? 4. Square root of 25 is 5i. 4 times 5 is 20. I times I is I squared. It changes the sign in front. So it's -20. Or we could do 20 times -1 equals -20. That's the answer. It was similar to the one we just did about 10 minutes ago. One plus 2i times 1 plus 3i. Yep. I'll let y'all do this real quick. So 1 times 1 is 1. They're all positive, so the signs are all positive. 1 times 3, 3i. 2 times 1 is 2i. 2 times 3 is 6. I times I is I squared. Let's combine like terms. We have 1 plus 5i. The I squared changes the sign in front. Becomes a -6. -6 plus 1 is -5 plus 5i. Very good. All right, so you guys are comfortable with this. What if we had this? To begin with, if I gave you 3 squared, what does that mean? How would I expand that? 3 times 3, right? So the exponent says multiply the base to itself that many number of times. So we do the same thing here. We have 3 minus 7i times 3 minus 7i. Now we multiply. 3 times 3 is 9. Positive times negative is negative. 3 times 7 is 21. I. Negative times positive is negative. 3 times 7 is 21i. Negative times negative is positive. 7 times 7 is 49i squared. Combine like terms. They're both negatives. 21 plus 21 is 42i. Plus 49i squared. The I squared changes the sign in front of that one, so it becomes 9 minus 42i minus 49. Nine minus 49 is bigger, so it's negative. 49 minus 9 is 40 minus 42i. That's the answer. I see what you all did. You cannot distribute. If it's got a plus or minus inside the parentheses, you cannot distribute inside there. Only if it was 3 times x, if it was multiplied, then you could distribute in there. But if it's got a plus or minus, that's one equation, and we have to multiply them all out. Did that simplify it some? Okay, remember I said you cannot have exponents on imaginary numbers. What if I gave you that? What we have to do is figure out now, what would that be? So let's look for a pattern. We know that I is equal to what? Is I. This is called I. I squared is -1. I to the power 3 is I times I squared, which is I times -1, makes it negative I. I to the 4th is the same thing as I times I cubed. So it's I cubed, we just figured out was negative I. So we have negative I squared. What's I squared? Is -1. So the negative of -1 is +1. I to the 5th is I times I to the 4th. There's 5 i's. So we have I to the 4th is 1. So it's just I. I to the power 6 is I times I to the 5th. This is what's called inductive reasoning. I'm taking what I've learned in the past and applying it and coming up with a new conclusion. So I'm always using the one before. So I to the 5th is I. So I got I times I is I squared. I squared is the same thing as -1. I to the 7th is I times I to the 6th. I to the 6 is -1, so it's negative I. Then I to the 8th is I times I to the 7th. which is I times negative I, makes it negative I squared. Negative, negative 1 makes it a positive 1. We start seeing it's repeating itself now. So what we have here is this. We have I squared, I cubed, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth. So we start off with I. I squared is negative 1. I cubed is negative I to the fourth is 1. I to the fifth is I to the sixth is negative 1. I to the seventh is negative I, and I to the eighth is 1. So once we see a pattern forming here, we can now expand it, extrapolate it for larger equations. So if we notice, it always repeats in groups of 4. So this is, so I to the first is just I squared is that. So this is what it's telling us. Since these repeat in groups of 4, we take the exponent, divide it by 4, because that's it repeats in groups. So that's going to, 4 goes into 4 once. With how many left over? So it's easier if we do it this way. 4 goes into 4 once. 1 times 4 is 4. We only look at this number here, the remainder. And if you look at these exponents, the exponents equal the remainder. If the remainder is 1, 2, 3, or 0. If the remainder is 1, the answer is I. If the remainder is 2, the answer is negative 1. If the answer is 3, the answer is negative I. And if it's 0, it's 1. Now, how do you memorize this? If you were running in a race and you won, what would you yell besides, I can't believe I finished? You won, I won, I won. I won, I won. The middle two are negative. It'll work, trust me. So remember, I won, middle two are negative, and those are your remainders. 1, 2, 3. Why is this one 0? Because if you divide 4 divided by 4, it's 1.0. So that's why the remainder is 0. So in this case, the remainder is 3. So this one becomes negative I. That's how you simplify that one. Let's look at example 4. What is I to the power 37. B is I to the power 58. C, I to the power 75. And D, I to the power 80. So the first one, how many times does 4 go into 37? 4 times 9 is 36. So we have one remainder. 1, 2, 3, 0. This is our remainder. This is our I. So it's I1, I1, the middle two are negative. So the remainder is 1. So the answer is I. B, how many times does 4 go into 58? 4 goes into 5 once. And bring that one down. Yeah, yes. 4 goes into 18 4 times. So the remainder is 2. Since the remainder is 2, the answer is -1. Four goes into 75. So let me see, 4 goes into 7 once. Makes it 35. 4 goes into 35. Because 4 times 9 is 36. So 4 times 8 is 32. The remainder is 3. So the answer is -I. And the last one, 4 goes into 80 20 times, remainder is 0. So the answer is 1. The hardest part about those is doing basic division without a calculator. Because you don't need a decimal, what you'll need is a remainder. All right. The last part deals with division. The rule about complex numbers. You cannot have an I in the denominator. So if you only have a single term, let's say we had 3 over 4i. If you have a single monomial, single term on the bottom, then multiply the top and bottom by I. because we have to get rid of the I. So we get 3 times I is 3I. 4I times I is 4I squared. I squared is -1. So the answer becomes -3I over 4. What if you had this? What would you do? What would you do in this example? You could. Why not just cancel the i's? And there's your answer. Again, if you only have a monomial, a single term on the bottom that has an I, all you have to do is get rid of the I. So multiply the top and the bottom by I. So 2 times I is 2I plus 3I times I is 3I squared over 4I times I is I squared. The I squareds change the sign in front of them. So we have 2I minus 3 over -4. And this negative distribute it to the top. So on the top, we have -2I plus 3. And then rewrite it in the standard form, which is number minus imaginary over the number. And there you have it. So that's if you have a monomial on the bottom, a single term with an I. Complex conjugate. For example, if I had -8I, what would I multiply to that to get rid of the I? What's the complex conjugate? The conjugate simply means change the sign of the I term. I would multiply to this one 8I. So I have negative times positive is negative. 8 times 8 is 64. I times I is I squared. This I squared changes the sign, so it becomes positive 64. What's the conjugate of this one? 2 plus 3i. Just change the sign in front of the I term. And we'll see what happens here when we do that. These are called complex conjugates of each other. 2 times 2 is 4. Positive times negative is negative. 2 times 3 is 6i. Positive times positive is positive. 3 times 2 is 6i. Positive times negative is negative. 9i squared. The 6i's cancel. So we're left with 4 minus 9i squared. It becomes 4 plus 9, which becomes 13. What's the conjugate of this one? Very good. Negative 4 plus 2i. So we have negative 4 times negative 4 is positive 16. Positive times negative is negative 8i. Negative negative makes it a positive 8i. Negative 4i squared. So you see that the conjugates always cancel out the middle terms. So we have 16 minus 4i squared. The I squared changes that sign, so it's 16 plus 4, 20. Make it 3 minus 5i. What's its conjugate? 3 plus 5i. It equals 34. Three times 3 is 9, plus 15i, minus 15i, minus 25i squared. Those cancel. That changes sign. 9 plus 25 is 34. You see the shortcut. If you have complex conjugates, the same numbers, just the sign, this one sign changes in front of the I. If you take the first number and square it, plus the second number and square it, you'll get the answer. Negative 4 squared is what? Negative 4 times negative 4 is positive 16. 2 squared is 4, which is 20. 2 squared is 4. 3 squared is 9. So in other words, if I had 2 plus 3i minus 4 minus 5i, I can't have an I on the bottom, so I have to get rid of it. What do I multiply by? I multiply the top and bottom by the conjugate of this. So it's 4 plus 5i. 4 plus 5i. Whatever the conjugate of the denominator is, you have to multiply it top and bottom. So what's the bottom number going to become? Four squared is what? 16. And then 5 squared is 25. 16 plus 25 is 41. So the bottom, half the work is gone already. We just now have to fix the top. 2 times 4 is 8. They're both positive. 2 times 5 is 10. They're both positive. 3 times 4 is 12. 3 times 5 is 15i squared. Combine like terms. So we have 8. 10 plus 12 is 22i minus 15 because it changes the sign. Negative 15 plus 8 is negative 7 plus 22i over 41. And there's your answer. Let's do one more and we'll call it the time of death. We'll call it triad 5 till. 2 minus 5i divided by 1 minus 6i. So we set it up 2 minus 5i over 1 minus 6i. What do we multiply by? 1 plus 6i. 1 plus 6i. Has to be to the same numbers, top and bottom. So what's the bottom number going to become? 1 squared is 1. 6 squared is 36. Add those together, you get 37. So that 2 times 1 is 2. 2 times 6 is 12. Negative 5 times 1 is negative 5. Negative 5 times positive 6 is negative 30i squared. Combine these two. 12 and 5, they're opposite signs. 12 is bigger, so it's positive. 12 minus 5 is 7i. This I squared changes that negative into a positive 30. 30 plus 2 is 32 plus 7i over 37. And that's the end of 3.1.